Welcome to Manifested Publishers.
Hello learners, welcome to Manifested Online Classes. My name is Mwaniki and we are learning Chemistry Form 2. Our topic is simple classification of substances. And the subtopic we are dealing with separation of solid-solid mixtures. In our previous lesson, we discussed how you can be able to separate a mixture of iron filings and sulfur. Iron filings is a gray solid, while sulfur is a yellow solid. Therefore, we say that when you mix them together, when you combine the two mixtures, you have a gray-yellow mixture. A gray-yellow mixture. If you put this gray-yellow mixture on a piece of paper and run a magnet over the gray-yellow mixture, then you realize that the magnet is attracting the gray solid, leaving behind the yellow solid. And therefore, this method of separation, we called it use of a magnet. And we said it is possible to separate the two because iron is magnetic while sulfur is not. And that is the method we called use of a magnet. And therefore, to separate the two, then you have one which is magnetic, in that case was iron filings, and the other solid was sulfur, and it was not magnetic. And that is how you are able to separate the two. Then again, we say that this method can be applied in glass making or glass recycling to remove the iron particles, and also in flour mills to remove iron particles. In this lesson, we are going to discuss separation of another solid mixture, and in this case, it will be separation of sodium chloride and iodine. Therefore, separation sodium chloride and iodine. Sodium chloride is a white solid. This is a white solid. Iodine is a shiny black crystals. Sodium chloride is a white solid, while iodine is shiny black, or they're just shiny black crystals. Then for you to be able to separate them, then you'll have the following apparatus. You will need a beaker, you will need a watch glass, then you'll also need a source of heat, and the source of heat will be the Bunsen burner, and you also need water for you to be able to separate them. Therefore, I want to draw the experiment or the diagram to show how you can be able to separate the mixture of sodium chloride and iodine. That is my diagram. Then to explain to you what that diagram is, so I have the watch glass which is holding cold water. There's a beaker which is holding the mixture. And this mixture is a mixture of sodium chloride, the sodium chloride and iodine. That is the mixture I have inside my beaker. Then I have the wire gauze. The wire gauze is on top of a tripod stand. This is what we call a tripod stand. I hope you remember the function of the wire gauze. The wire gauze, maybe to remind you, is used for even or uniform distribution of heat. And we want this heat to be distributed over this surface or over the bottom of the wool beaker. Then you use a wire gauze to ensure that heat is distributed uniformly or evenly. Then I have the source of heat. This heat is now coming from a Bunsen burner flame. And remember again in the previous topic, we said that the flame we use mostly in heating in the laboratory, we use a non-luminous flame. We use a non-luminous flame because of two reasons. One, it is hotter than the luminous flame. And second, it does not produce soot. Therefore, it's not going to dirtify the beaker at the bottom with that black solid we call soot. Therefore, what we expect is going to happen is when you heat a mixture of sodium chloride and iodine, when you heat a mixture of sodium chloride and iodine, you expect that iodine is going to turn into a gas. Iodine changes directly into vapor. And this vapor is purple in color. Therefore, after some time when you are heating, then this iodine, you are going to see the purple vapor moving up from this solid, because iodine changes directly from a solid to vapor, directly from solid into vapor. The function of the cold water, there's cold water which is held by the watch glass. The function of this cold water is to cool the hot iodine vapor. To cool the hot iodine vapor. Therefore, iodine decomposes or changes from a solid to a gas directly. And therefore, after some time, we're going to see all the iodine will be at the bottom of that glass beaker. Once you remove that glass beaker after all the iodine has changed from solid to gas, then you pour this water and you leave it to cool. Then you realize that this purple iodine vapor changes back to shiny black crystals. The purple iodine vapor changes back into the shiny black crystals. That is what is going to happen when you pour this water and you cool the watch glass. And then here you are left with the white solid which is sodium chloride. Then any substance which is able to turn from a solid to a gas, we say that process is called sublimation. Therefore, sublimation is a process by which a solid changes directly changes directly to a gas. Sublimation is a process by which a solid changes directly into a gas. And we have seen iodine changing directly from a solid into a gas. The iodine vapor is a gas we are talking about. So it is not passing through the liquid state. It is directed from solid to gas without passing through the liquid state. Then after you have poured the water from the watch glass and allowed it to cool, then this gas has solidified, or it has turned back into a solid. And that's why iodine vapor is now cooling into the shiny black crystals once again. And therefore, that process, we call it deposition. Deposition. Therefore, deposition is a process by which a gas changes directly into a solid without passing through the liquid state. The process by which a gas changes directly into a solid without passing through the liquid state. That is what you call deposition. Process by which a gas changes directly process by which a gas changes directly into a solid without passing through the liquid state. That is what you call deposition. And therefore, you need to understand these two very important terms very well. Remember, we are still looking at the separation of sodium chloride and iodine. And therefore, the method which has helped us separate a mixture of sodium chloride and iodine is sublimation method. Sublimation method. So sublimation method has made it possible for us to be able to separate sodium chloride and iodine, because when we heated the mixture of the two, there was a mixture inside here. When you heated a mixture of the two, the iodine has turned directly from a solid to gas. And that gas has cooled over, or has cooled on, the lower surface of the watch glass, which is having the cold water. And then we have seen that the cold water is just cooling the iodine vapor. And that is the sublimation method. And we have seen that sublimation is that process by which a solid changes directly into a gas. And therefore, sublimation has made it possible for us to be able to separate a mixture of sodium chloride and iodine. Therefore, we can say that iodine undergoes sublimation process. Iodine undergoes sublimation process. Sublimation process, this just means from solid to gas. This is what we are calling sublimation. Then now from gas to solid, this is what we are calling deposition. Therefore, this is sublimation. and this is deposition process. Iodine can undergo those two processes. I want to give you other examples of substances which can undergo through the same process. Other examples of those substances which can undergo the same process of changing from solid to gas directly include aluminium chloride and anhydrous iron 3 chloride. We have solid carbon dioxide. We have ammonium chloride. Those are just other examples of substances which can undergo sublimation process. Maybe we can include them in our list. All other examples. Aluminium chloride, ammonium chloride, anhydrous iron 3 chloride, and we have solid carbon dioxide. Solid carbon dioxide. Therefore, those substances can be able to undergo sublimation process, meaning that they can be able to undergo or change from a solid to a gas directly. Sublimation process. Right now, I want us to look at the application of this method. Where can this sublimation method be applied? Application. We say that dry ice, I forgot to tell you that sodium carbonate or solid carbon dioxide is also called dry ice. Dry ice. Therefore, you can see that dry ice is used by ice cream vendors. I hope you've come across the ice cream vendors. These are just people who are selling ice cream, and therefore they mostly use the dry ice in cooling or in their ice boxes. Dry ice is used by ice cream vendors in their ice boxes so that they can be able to keep the ice cold. And there are two advantages of using dry ice over ordinary ice. Advantages of using dry ice over ordinary ice. One, it is a better coolant. Dry ice is a better coolant. Dry ice is a better coolant compared to ordinary ice. When you talk about the ordinary ice, this is water in solid form. That is what you call ordinary ice. And dry ice is solid carbon dioxide, as you have said there. So this is one of the advantages of dry ice over ordinary ice. And second is that it is sublimes, leaving no wetness. It sublimes, leaving no wetness. When you talk about subliming, this is now the change from a solid to gas direct. Change from solid to gas direct. That is what we are calling subliming. Dry ice or solid carbon dioxide is able to sublime while ordinary ice does not. Therefore, it does not wet. Does not wet the vendor's goods. So if you are preserving something, or if you want to keep something under low temperatures, it means that if it's able to sublime without leaving any wetness, it means that it cannot be able to wet whatever you are keeping under certain temperatures, while ordinary ice will just change from solid into a liquid and it will be wet all over. Therefore, those are the advantages of using dry ice over the ordinary ice. Then the application, again, don't forget, the dry ice is used in cold boxes by ice cream vendors. So that was our lesson today. And I want maybe to go through what we have discussed in this lesson. In this lesson, we were discussing separation of solid-solid mixtures, and our solid-solid mixture was sodium chloride and iodine. I told you that sodium chloride is a white solid, while iodine is a shiny black solid, or like shiny black crystals. When you put them together, or when you mix them together, then you'll have a white-gray solid. Is a white-gray solid. When you put this white-gray solid in a beaker like this, then you are heating it. Then over there is a watch glass with cold water. Then this iodine is now going to change from a solid to a gas direct. And I've told you that the color of this gas is purple. It is just purple vapor. And the function of this cold water is just to cool the iodine, cool the hot iodine vapor. Therefore, after that, when you remove this or remove the watch glass, you pour the water, it cools. Then again, you are going to get back the shiny black crystals. And that is now what you have called deposition method. Deposition is now that change from a gas to a solid direct without passing through the liquid state, while the solid and changed from a solid direct into a gas without passing through the liquid state. So solid to gas, sublimation; gas to solid, deposition. Then this solid to gas, sublimation; then gas to solid, deposition. And iodine is one of the substances which are able to undergo that process. And I've given you again other examples of substances which undergoes sublimation. I've told you we have aluminum chloride, we have ammonium chloride, we have anhydrous iron 3 chloride, and there's also solid carbon dioxide, which is also called a dry ice. Then we have looked at the application. The application, I've told you that dry ice is used in cold boxes by ice cream vendors. And I've told you that vendors, they're just the people who are dealing with the selling of ice cream. Then again, we have discussed the advantages of using dry ice over the ordinary ice. And I've told you that one, that dry ice is a better coolant compared to the ordinary ice. And second, it sublimes, leaving no wetness. Subliming means that it is able to change from a solid to a gas direct, and therefore it is not going to wet the goods of the person using it. And therefore, that brings us to the end of our lesson today. But before we end, I want to leave you with this assignment. Name 3 substances which can undergo sublimation process. We have named them. Then ensure that you've done that before we meet in the next lesson. In the next lesson, we'll be discussing separation of solid liquid mixtures. Meet you in that lesson. Bye.